And now this curve C and the curve L, they are going to intersect. And the point that they intersect is indicated by point M, and what we want to do is to form an equation in terms of t at point M. To do that, I'm going to solve this as simultaneous equation. That means x is equal to 3t squared. I can let it be my first equation. Y is equal to 2t to the power of 3. I can let it be my second equation. And x is equal to y squared plus 1. I'm going to let it be the third equation. And what I'm going to do to form an equation in terms of just t, where it is, I'm going to take equation number 1 and equation number 2. I'm going to plug it into equation number 3. Okay, so this going to here, it is going to be 3t squared is equal to this going to y, it is going to be 2t to the power of 3 squared plus 1. Okay, so this is 3t squared. This is going to be equal to 4t to the power of 6 plus 1. So now we have it 4t to the power of 6 minus 3t squared plus 1 is equal to 0. And this is what the question wants us to show. Okay, and next what the question wants is for us to find the exact coordinates of M. To do that, we need to first find the exact solution to t of this equation. But sadly, if you were to try to press this into your graphing calculator, the t that you're going to obtain, it is going to be some irrational numbers. So it is not the exact form. So the next challenge is to try to solve for the value of t in its exact form. And to do that, I got to do a bit of trial and error. Okay, what I'm going to try is I'm going to try to re-express this to make it in terms of t squared. Okay, what I mean is, for example, t to the power of 6, I'm going to rewrite it as t squared to the power of 3. Okay, then it will be minus 3t squared plus 1 is equal to 0. What I'm trying to say is I'm trying to visualize this whole equation here, right, as if I'm replacing t squared by u. Okay, which means that solving this equation is similar to first solving the equation of 4u to the power of 3 minus 3u plus 1 is equal to 0. Because when it's re-expressed in this form, right, when I press into my calculator to solve for the roots, okay, it is going to be nice rational roots. Okay, from my calculator, solving for the roots of this equation is going to help me to get the factors. The factors are going to be u plus 1 and 2u minus 1 squared is equal to 0, which means that since u is equal to t squared, what I'm going to have here is a t squared plus 1 and 2 t squared minus 1 squared is equal to 0. Okay, this is always going to be positive. So what I'm going to be left with is t squared minus 1. This got to be equal to 0. So t squared is going to be 1 over 2. T is going to be plus or minus 1 over square root of 2. Okay, but if you were to look at the question actually tells me something. Okay, the question tells me that y is supposed to be bigger or equal to 0 because we are looking at only the top portion over here. So with this, right, if you were to look at what the x and y coordinate can be, okay, can you see that I'm going to reject the negative 1 over square root 2 because if I were to sub negative 1 over square root 2 into here, I'm going to get a negative y coordinate, okay, which is not what I want. So t is going to be just positive of 1 over square root of 2, okay, and this is because the question says that y is bigger or equal to 0. Okay, to get the exact value of the coordinates of M, definitely I'm going to let t be equal to 1 over square root of 2 and substituting that back into equation number 1 and 2 to get the x and y coordinates at M. Okay, so substituting this back into equation number 1, I'll get the x coordinate of M to be 3 multiplied by 1 over square root of 2 squared. This is 3 over 2. And y is going to be equal to 2 times 1 over square root of 2 to the power of 3. And this is going to be 1 over square root of 2. And that is why the exact coordinate of M is going to be 3 over 2 and 1 over square root of 2.